Hello guys, this is CodeNCode and today we are going to start a new series on square root decomposition. So this is the first lecture on that. Let's get started. So uh, first of all, in this lecture we are going to look at these two things. First, why we need square root decomposition, and the second one is introduction and implementation of square root decomposition. So first thing first, why we need square root decomposition. Why learn square root decomposition, where square root decomposition is just another uh, way of answering queries, like it is one of the range query solutions like segment tree or Fenwick tree. So why we need this? So there are many things which you can solve using segment tree, but there are some which you cannot solve using segment tree. For example, this question. Says that you are given an array of size n with n element in it, and there are q queries. In each query, you are given two parameters L and R. From L to R in the array, you have to count the number of unique elements. So just imagine doing this using segment tree. So one way you can do it is that in each node you can save the number of unique elements in their region. For example, in 1 to 3 there are 3 unique elements, 1, 2 and 3, and 4 to 6 there are 3 unique elements again, 3, 4 and 5. So 1 to 3 and 4 to 6 are having 3 and 3, but as we know, in segment tree the parent node uses the solution of their children to make their own solution. So it would take this and this, add up that and make 6, but we know from 1 to 6 there are not 6 unique elements but 5. And why this is happening? Because there are some intersection between these two which we have to remove, and that is why in each node it is not a good idea to store the number of unique elements from L to R. Other way you can solve it is that at each node you can store a set of integers in that range. So 1 to 3 would contain 1 to 3's range would contain integer 1, 2 and 3 from the array. 4 to 6 would contain integer 3, 4 and 5. Now 1 to 6, what it would do is take integer from this range and merge them, and now the set contains only 5 elements, which is true. From 1 to 6 there are only 5 unique elements. So this way you can have a set at each node of segment tree. But the problem here is that now to find the answer of a range, you have to merge all the elements of that range into a set, which is not very efficient, because in worst case it would be n log n operation. So we can see that each query would be answered in n log n, which is quite costly. It's not log n but n log n. Just try to think solution of this problem using segment tree, then you will know that why segment tree cannot solve this problem efficiently. So these kind of questions can be answered using Mohs algorithm, which is a variation of square root decomposition, because that is square root decomposition on queries. So you can solve these kind of questions using Mohs algorithm in n into square root of n time, basically n raised to power 3 by 2 time, we go of n raised to power 3 by 2. So that is why there are some cases where you cannot actually apply segment tree, but you can apply Mohs algorithm or square root decomposition. So that is why we need square root decomposition. So now the second part, introduction to square root decomposition. So square root decomposition just what it does is it takes the input and now it creates block of size square root of n. And for the proof of why we need a size of why the block size have to be square root of n. The proof of that you can find in the Wikipedia page. I've put the link in the description. So what it does, it creates square root of n blocks, each block storing the solution of all the elements of their block. So just do this. The total number of elements in the array were 12, so square root of 12 is something like 3 if you take the round of floor of square root of 12, so it is going to be 3. So we would have 4 blocks of size 3. This block, the 0th block, contains answer of 0 to 2. This is another array just of size 4. Why? Because our block size is 3 and total number of elements are 12. So 12 divided by 3 is 4. So we need 4 blocks, and it is not always necessary that this is completely divisible. In that case, you would have an extra block. For example, if there were 13 elements and the block size would have been 3, 13 divided by 3 is like again 4. So you need actually 5 blocks, because the extra element have to be stored somewhere, the answer of extra element. So first of all, calculate the block size. That is going to be square root of n, floor value of square root of n, or ceil value, whatever you want. So in this case we have taken floor value, which is 3. So our block size is 3. So this actually is array, 0th index, 1st, 2nd and 3rd. All we need 4 places in the array. So 0th index of this array contains answer from 0 to 2. By the way, this question asks you, given L and R, you have to find the minimum in the range of L to R. So the first block saves answer from 3 to 5, second block saves answer of 6 to 8, and then the third block contains the answer of 9 to 11. Imagine if there were 10 to the power 4 elements, then square root of 10 to the power 4 is obviously 100. So each block would contain answer of 100 elements. For example, the 0th block would contain answer of 0 to 99, all the elements from 0 to 99. The first block would contain answer from 100 to 199, and so on. So now what we can do, we can calculate the answer of each block and save them here, so that when there is a query something like from 2 to 7, then what we can do, we can take answer of this block directly from here. So at max we have to, since there are the block size is square root of n, so we need a square root of n blocks, because block size is square root of n, total number of elements are n, and divided by square root of n is equals to square root of n. So there are square root of n blocks. Even if in the worst case the query comes from 0 to n minus 1, you can answer the query in square root of n time, because in between you have square root of n blocks and you can directly take answers from them. First block contains answer from 0 to 2. You took this answer, you know what is the minimum from here to here. Now you went to the first index into this array and took the minimum from here to here. So you can, all you can do is go from 0 to the 3rd index and take minimum of all this, which would come out to be 1, and you can answer the whole query in square root of n time. So let's see the how the query is answered. Sorry. Sorry. So let's see how the query is answered. So suppose first thing what you have to do when L and R comes, this array you have to generate yourself from the input. So why we are taking from 0th index is that when you have calculated block size to be 3, now you from 0 to 2 we know belong to the 0th index. Why? Because 0 to 2 any index divided by 3 comes out to be 0. That is why they all belong to the 0th index. Now 3 to 5, every index divided by 3 gives 1. 3 by 3, 4 by 3 and 5 by 3 gives 1. So it tells that these 3 indexes indices belong to the first block, and similarly for these three, dividing by 3 would come out to be 2, and so on. That is why we are taking from 0 index, not from the 1 index. You can take the input from index 1 base index, but then you have to do a little extra calculation. So if the query comes, first of all, what we L and R, you have to find out their blocks. So suppose there is a query of 1 to 10. Now just you have to find the minimum from here to here. There are two type of queries. First, not two type of query. The query can be answered in two way. First of all, when L and R comes, you have to find the blocks of L and R. So here 1 divided by 3 is 0, so starting the L lies in the 0th block, and we can see that yes, first index lies in the 0th blocks. And 10 divided by 3 is 3, so 10 lies in the 3rd block. So that is why starting in the left block and the right block are 0 and 3. If they were in the same block, what we can do, for example, if the query was to be answered from 3 to 5, now 3 divided by 3 and 5 divided by 3 both are 1, so LB, that is left block and right block, would have been 1 and 1. So if they lie in the same block, L and R, then what we can do, we can linearly traverse all the elements from L to R and answer the query. This would be done in square root of n, because each block size is of a square root of n, and traversing a block requires only square root of n time. That is why the query could be answered in square root of n time. But if left block and the right block are not same, that is they lie in the different blocks, now we can use this array to utilize. For example, we have to start from here and we have to go all the way till 10th index. So let's see how we can answer that. So we initialize our minimum to be infinity, and now we starting from the left block. We have to traverse all the elements of left block. We cannot take answer from here directly because it contains answer of all these three elements. But since our starting index is 1, which may the starting index, that is L, may and may not contain all the elements of that block, that is 0th block. So it is always a good idea to linearly traverse all the element in the left block. Similarly for right block. So what we would do, we would start linearly traversing all the elements in the left block starting from Lth index, that is 1. So starting from index 1, 5, minimum would be in minimum of infinity comma 5, so answer would be 5. Now the second element, so minimum would become 2. Now how do you know that where you have to stop? So starting from L, you have to go, we have to traverse all the elements before the starting of the next block. So next block start from 3rd. How we know it starts from 3rd? We know the block size is 3 and it is the first block. Next block is first block because current block is 0th. So a starting position of next block is 1 into 3, that is block number multiplied by block size. So block number is 1 and block size is 3, so 1 into 3 is 3. So you have to traverse all the elements starting from 1 but less than 3. So 1 and 2, you have traversed 1 and 2, so minimum is 2. Now you can traverse by blocks because we know this and this, all the blocks before the right blocks, because we know the 3rd block or the right block, the answer of our query may or may not contain all the elements from the right block. So what we can do is we can traverse now, we can take answer from the blocks which are less than our block. So we can take this and this. We don't have to traverse these linearly. We can take answer of this segment from this, only a single element from F array. So what we would do is now we would start traversing block by block. So we would traverse first block and second block because 2 is less than 3. So we would go till right block minus 1. So we traverse the first index starting from first block, because L block we have traversed. Now starting from L block plus 1 less than R block. So answer of these three indices is this. So we update our minimum, which would not change at all, and then again we've traversed the second block, the answer would not change again. And now at last, now starting from L block plus 1 to less than R, now the last block, that is the right block. As we know, the right block may or may not contain all the elements of the right block, so we cannot take answer from here directly. Now at last we would do again the same thing, starting from the starting of the right block, that is starting of the right block you can find is by 3 into 3, because block number multiplied by block size. So 9, starting from 9 we would go all the way till R. So starting from 9, minimum would be minimum of 2 comma 4, so 2, and minimum would be, now that till 10, minimum would be minimum of 2 comma 1, that is 1. So answer of 1 to 10 have answered in square root of n time. Why square root of n time? Because we know L left block and right block we are traversing linearly. So traversing linearly, two blocks would take 2 into square root of n time. Now the remaining blocks can be at max square root of n, because there are only square root of n blocks. So at max the query would be answered in 3 into square root of n times, which is as good as square root of n times. So each query can be answered in square root of n time using square root decomposition. The same square root decomposition can be used to answer many other queries like range maximum query, range sum query, and so on. So there is a question on Spoj, that is finding the range minimum query. So I would put the link of that problem into the description. Please be sure to solve that problem. So this is the implementation of the function, which takes two arguments L and R to give the minimum, and it assumes that F array, this array you have already calculated. This is the answer of each block, ith block. F of I contains the answer of the ith block. So whenever L and R comes, first of all you have to calculate the left block and the right block. So left block is equals to L divided by block size, of course, and R block is equals to R divided by block size. Now about the block size, there are as I've already told you that block size is equals to square root of n. Yeah, that is true, but still calculating if there are t test cases, so calculating block size in each test case is not a good idea. So it is better to use a constant as block, like take if n is equals to, in worst case, in the input array, if n is a million, that is 10 to the power 6, you can take square root of n as a 10 to the power 3 directly. Or if n is equals to 10 to the power 5, you can use block of 700. You don't have to calculate it again and again. It enhances the running time, because working with the compilers work better with constant rather than computing them again. So it is better to use a constant of block size rather than calculating it again and again. And I have seen a many very good programmers doing the same, including me. Whether I am not a good programmer. So first of all, calculate the left and the right block, and then initialize the answer to be int max. It is int max is defined. It is already defined a constant. Now if L block is equals to R block, as we have already discussed, if both the indices lie in the same block, what we can do, we can directly traverse from L to R linearly and update the answer accordingly. Now if they belong to different block, what we would do first, as you know, starting from L and less than to next block, we would traverse linearly. Now starting from LB plus 1 less than RB, we would traverse block by block, and at last starting from the right block, we would go till r again linearly, and in each time updating the answer to be minimum of mn comma ar of I or f of I, and at last returning mn, that is answer. So this way you can answer. Actually this is directly implementation of the question that I'm going to give you, the this link of from Sponge. So try to solve that problem, and thank you guys for watching, and thank you for being with me. Thank you.